So in this tutorial I will show you how to make a car parking system or a car parking project that you should be given while studying electrical engineering, software engineering, or maybe electronics engineering. So first of all, to make that project you need a code. I have made that code previously. Let me show you the code. It is the code. This code is for common cathode 7 segment display. You can change it accordingly if you have common anode 7 segment display. You can change it by changing these values. For example, these values are for common cathode. For example, these are giving 1 as a output, and as the 7 segment display is common cathode, so the values should be high. The values on which the LEDs should be high, because the common of the 7 segment display is connected to cathode. Then all the values going to 7 segment display should be high, means at least 5 volt or required voltage to make the LED segment on. If it is common anode, just take the you can say opposite of these values. For example, as you know that 3F in hexa, it means let me show you. 3F means 0 0 1 1 for 3 and 1 1 1 1 for F. If it is common anode, you just do it by converting ones into twos and ones into zeros and zeros into 1. So you will simply do like 1 1 0 0 and 0 0 0 0 and rewrite it in hexa or in decimal, in whatever you want to write. For example, it would be 8 and 1 9 8 9 10 11 12 12 in hexa would be A B C C and 0. So it's up to you to change these values accordingly. Secondly, interrupt 0 and interrupt 1 is used for that purpose. Okay, and the registers that control the interrupts are is GICR register. It is given here. The last 3 bits, and it means high bits of GICR register, general interrupt control registers, are controlling interrupt 0, and the last one D7. The 7th bit is for int 1, 6th is for int 0, and 5th is for int 1. So as we are using here the last 2 bits, it means 6th and 7th, because 6th is for interrupt 0 and 7th is for interrupt 1. So if you write it in the form like this one is for interrupt 1, another one for interrupt 0, and all other values are 0, because all the other values must not be used here. So with 1 1 0 0, it is for 1 1 0 0 is for 1 for 9 10 11 12 13. Sorry. So 1 for 8 9 10 11 12 12, and 12 in hexa is for C, and it is written C, and it is 0 0. So similarly, if you want to use interrupt 2, you should place 1 here. It depends on what interrupt pins you want to use, and it is for ATmega 16. So ATmega 6, the pin number 16 and the pin number I think 16 is for interrupt 0 and 1 accordingly. So it is up to you to use whatever interrupt signal you want. And so two interrupts are called here. This one is for interrupt 0, and interrupt 0 is for count up, interrupt 1 is for count down, and these values. So and DDR register A is used here. You'd for as this port do not need a DC converter, so therefore this is used here, and it is initialized to 0 0. This MCUCR register is used for controlling the interrupts. For example, if you want let me show you something. This is for AVR control interrupts. For example, these are the bits. You have to use interrupt for interrupt 0 these bits, 2 bits, and for interrupt 1 these 2 bits. If you want your project to be level controlled, you have to place 0 0 here, and for the purpose I have made it falling edge. It depends on your choice, whatever you want to choose. If you want to make interrupt 1 rising edge controlled, just place 1 1 here and interrupt 0 similarly here. So that was all about the MCUCR register. So I have written 0x0a. In fact, F should be written here. So if you write F, you are making it rising edge controlled. Okay, so it is written here. Now this end was purposely used here because you don't want other bits to be disrupted, just you want the 2 bits 1, not other bits. The other bits, the values of other bits would stay what they are initially or in any way initialized. So just last 2 bits, in fact first 2 bits are 1, and the values of other bits would be same as they were before. This was all code. Now it is up to you to use the same algorithm to make the code in whatever language you want to use. I have used ATmega 16 compiler. Just compile this code and make the hex file and burn it on ATmega 16. If you want your code, if you want to check your code, you can do it on Proteus. For interrupt signals, you can use